In electronic chips, data transfer is limited by the electrical resistance of the materials and the capacitance of the circuits, which causes delays and energy loss. And WAIS is its own all-in-one photonic computing chip. It combines traditional electronics with photonics to perform computations using light. This isn't just a small upgrade, it's a completely different way of thinking about computation. Imagine data flowing through the computer at literally the speed of light, using different colors to process multiple things at once. While traditional computers are stuck waiting for electrical signals to bounce back and forth, like a very fast ping pong game, light moves through these chips without any delay. And here's what's really clever. They can stack what light matter calls virtual processors on top of one another, almost like creating multiple computers in the same physical space. They're doing all this while using far less power than regular chips, which is amazing because energy is one of the biggest costs in computing today, especially for AI. This isn't just making computers a little better, it's reimagining how they work with light.
So this is the next generation passage, and it's able to communicate at over 100 terabits per second. So in this chip, we're able to attach 256 fibers, the largest optical fiber count in the world, and the highest bandwidth chip in the world.
Think of this as a superhighway for data passing between different chips. It uses light to transmit information between processors, enabling unprecedented bandwidth and ultra-low latency communication.
You take a customer GPU or a switch or a CPU, and you integrate it on top of Passage, and now those chips can communicate using light. So we realized that there were some fundamental challenges both with how chips do computation and how they transmit information between each other, especially in the context of these large AI workloads that use teraflops and petaflops of computation operations per second. And what we realized was that by using silicon photonics and using light, we would actually be able to drive the energy efficiency, drive the speed, and continue the roadmap for computing.